Welcome to The Explainer. Today, we are digging into a huge problem bubbling up in the world of AI. You see all these headlines, right? AIs are acing medical exams, writing perfect code, but what if it's all a scam? What if the smartest AIs are just the best at cheating? Let's get into it.
So here's the big puzzle we're going to try to solve today. How can an AI model be a certified genius on paper, absolutely crushing standardized tests, but then completely fall apart when you give it a simple, real-world problem? It's kind of like a high school valedictorian who can't figure out how to do their own laundry. Something just doesn't add up.
And look, we're not talking about a small mistake here. We are seeing models get these incredible, superhuman scores. We're talking over 90% on massive benchmarks like MMLU. But, and this is a huge but, researchers have found that these exact same models can just completely fail when you do something as simple as rephrase the question. It's a contradiction so big, it makes you wonder if the entire report card is just one big illusion. So, let's start our investigation.
All right, clue number one in our mystery is what I'm calling the cheating student problem. It turns out some of these AIs aren't actually learning the material at all. Nope, they're just getting really good at finding the answer key before the test. The technical term for this is data contamination. So imagine you're training an AI on, a giant chunk of the internet. The problem is that somewhere in that massive pile of data, the answers to the final exam have been leaked. So the AI isn't reasoning its way to the solution, it's just remembering it. And that right there is the huge difference between just spitting back information and actually being intelligent.
Okay, so if the answers are buried in literally trillions of data points, how in the world do you prove an AI has been peeking at the answers? It's not like you can just ask it. You need some kind of specialized digital detective to find the evidence.
And that detective has a name, MIA. This thing is a brilliant new technique that can basically sniff out whether a specific piece of data, like a test question, was part of the AI's training diet. You can think of it like a forensic tool that just gets smarter and smarter with every pass, zeroing in on those little telltale signs of memorization.
And you know what? It works incredibly well. On a key benchmark for this kind of thing, EMIA hit a score of 0.72 AUC. Now, to put that in plain English, a perfect score is 1.0. That would mean the detective catches the cheater every single time. So getting to 0.72, that's a huge leap forward. It's a new state-of-the-art for our ability to catch these AIs red-handed.
But what about when the AI hasn't been cheating? Let's move on to our second clue, which is honestly a little more subtle and even more worrying. This is the problem of what I call the brittle parrot. An AI that can repeat what it's heard perfectly, but has absolutely zero real understanding of what it's saying.
So take a look at this. It's a pretty standard middle school science question, right? It's the kind of thing you'd expect any top-tier AI to get right in its sleep.
And yep, it gets it right. C, melting of ice. Looks like a genius, doesn't it? It clearly understands what a physical change is. Or does it? Hold that thought.
Now watch what happens when researchers ask the exact same question, but they just use different words. It's the same concept, solid water becoming liquid, but it's phrased in a way that avoids those specific keywords the AI might have just memorized.
And boom, just like that, our genius AI completely whiffs it. It now thinks the answer is corrosion. This is the brittleness problem in a nutshell. The AI didn't actually get the concept of a physical change. It just learned to connect a specific pattern of words to the answer melting of ice. Change the pattern, and the understanding just evaporates. And this chart really drives the point home. This isn't just a one-off mistake. For this particular model, its accuracy dropped by a full 10 percentage points just from rewording the questions. That's the difference between getting a solid B on a test and scraping by with a C-. It shows this terrifying gap between what we think the AI knows and what it actually gets.
Okay, so we've got cheating students and we've got brittle parrots, but our investigation isn't over. There's one last critical clue, and this one isn't about the students. It's about the teachers grading the tests, because it turns out the very AIs we're using to judge other AIs are coming in with their own major biases.
Yeah, these LLM judges are far from impartial. They have some really predictable flaws. For one, they tend to like the first answer they see more than the others. They also get impressed by long, complicated-sounding answers, even if that answer is total nonsense. And get this, they actually give higher scores to answers written by AIs from their own family. It's like a referee favoring their own kid's team in the championship game.
So this is a huge problem, right? You can't trust the results if the ref is biased. So how do you fix a rigged game? Well, researchers have come up with a much smarter way to keep score that actually accounts for these flawed judges.
The solution is a new framework called CARE. Instead of just taking a simple majority vote, think of it more like an Olympic judging panel, where they drop the highest and lowest scores to get a fair result. By carefully weighing each judge's opinion based on their known biases, CARE was able to reduce evaluation errors by a staggering 28.8%. That gives us a much more accurate picture of how an AI is really doing.
So, we've followed the clues. We've uncovered the cheating, the brittleness, the biased judges, and that brings us to the final core revelation of this entire mystery.
Let's just run through them one last time. First, our AIs are sometimes just cheating, memorizing answers from their training data. Second, even when they're not cheating, they can be incredibly fragile, showing no real understanding if you just change the wording of a question. And third, the AI judges we rely on to grade everything are themselves full of biases.
And this all leads to one simple, powerful conclusion. The problem isn't that any single AI is broken. The problem is that the entire system we've built to measure AI, our tests, our benchmarks, the very rulers we're using, is broken. We haven't been measuring intelligence. We've been measuring how good an AI is at passing a very specific, very flawed test.
So why does all this technical stuff matter to you, especially if you're a solopreneur or a business owner just trying to get work done? Well, it matters a whole lot, because it completely changes how you should think about adopting and trusting these powerful tools.
Here is your new playbook. First off, ignore the marketing hype. A 99% on some benchmark means nothing for your business. The only test that matters is how the AI performs on your specific tasks with your data. Second, prepare for things to get weird. Expect it to fail on simple things and always have a human checking the important stuff. Third, you need to actively look for this brittleness. Ask it the same thing 3 different ways. If you get 3 wildly different answers, you know you can't rely on it. And finally, and this is the most important part, you have to change your mental model. You are not talking to a junior colleague. You are operating a very powerful and sometimes very clueless pattern matching machine.
And that leaves us with this one big nagging question. As these models get more and more powerful, their ability to fake understanding is only going to get better. So how will we ever really know if an AI is truly smart or just a more convincing faker? Designing a ruler that can actually tell the difference, that is the real challenge that's going to define the entire next chapter of AI.